Hello and welcome to Talking Automotive with Mark and John. My name is John Sinclair. Today we're talking to David Jenkins from AutoTest. This is our second podcast with David. In this podcast we're going to talk about the future, where the market's going, the changes in the market and what's happening. A great podcast, so let's jump into it. Remember, if you like what you hear, subscribe to our channel on YouTube below. You can also find us on Spotify and iTunes and other podcatchers. We also have our own website, occurrence.com.
With 30 years' experience in auto logistics and state-of-the-art locations in 5 major Australian cities, Precar Fleet Services is an independent division of Precar Services, offering specialty fleet fit-outs for commercial applications ranging from simple tray and tow bar fitments to fully bespoke service body and accessory installation. With quality-assured safety, compliance and standardisation of vehicle builds, Precar Fleet Services are a premier all-in-one solutions provider for commercial vehicle fleet operators, leasing companies and original equipment manufacturers. For further information on how Precar Fleet Services can assist in solving your commercial vehicle fit-out needs, please visit precar.com.au and click on the link to Fleet Services.
Modera is a cloud-based AI-powered CRM and retail platform aimed at digitizing the physical process of selling a car. The Modera platform sits between existing automotive dealer and OEM systems, providing car dealerships a quick and easy shift to digital ways of working, all done entirely digitally and with total ease.
Hi David, thank you very much for joining us on the show again today. We enjoyed the first podcast with you and it's great to have you back again for our second one. So maybe just to kick off, can you tell us more about the future of measuring equipment and where do you see things changing in the future? Do you anticipate there's going to be major changes coming?
No, there are changes happening all the time. If you consider with the decelerometer where that started, post First World War, they used to do a brake test with a bag of chalk and a tape measure and a stopwatch. So these days we've got a very advanced piece of electronic equipment that does all of that with the push of a button. There have been huge advances. In the decelerometer space, we are introducing things like GPS, we're introducing tablets, we're certainly introducing modelling software, so the mining industry have used that extensively to model performance. And it is changing. The biggest changes that I see in this space, though, are probably in the emissions area, where things are changing very rapidly. We've got a whole industry potentially transitioning to some sort of hybrid methodology. Certainly for the transport industry, I think it will be hybrid, a combination of some sort of internal combustion engine and electric. The mining industry have, to some degree, converted to electric, but mainly it's regenerative braking. Yeah, certainly the instrumentation is changing quickly. In terms of emissions, we're going from what was originally a chemical-based sensor to probably, certainly a laser-based scattering device, so measuring particle size. So 10 years ago with smoke, we were all familiar with the black smoke from a diesel truck, the big puff that comes out when they put their foot on the accelerator. These days you don't see that, but it's not because it isn't there. The manufacturers to stem that have introduced what they call exhaust gas recirculation, so that they take the exhaust and they put it back through the engine again and burn the unburned fuel again. What that does is reduce the particle size. It's reducing it to the point where you can't visibly see it. It's still there. If you count the mass, it's the same mass, but particle size is so small that it's translucent. So the instrumentation has to move to measure that from, rather than measuring the density of the smoke or how black the smoke is, measuring the particle size. And some of these particles are what they call nanoparticles, so less than 10 microns in diameter. And from a health and safety point of view, that goes directly through your skin into your bloodstream. Whereas once they're bigger than 10 microns, they can't do that. So the whole nanoparticle argument covers, well, that's one area it covers. It covers sunscreens, makeup, all sorts of areas. So most commonly they talk about the microparticles in the ocean, the plastic particles. But it's another extrapolation. So developing instrumentation to deal with that is quite advanced, and from a challenging point of view, it's very challenging for the designers to have to do that, and a good exercise for them.
How do you keep up with the changes? Because it must be quite difficult. Do you attend particular shows?
Trade shows is one way, but the trade shows, the instrumentation is at the cutting edge, or what you would hope is at the cutting edge. That's not giving you the lead up, so it's really telling you what's already changed. So that's why we get involved in standards committees and things like CETA, where you have a group of people talking about what could be, and that seeds the ideas. So it's then the job of the designer to take that idea and go away and develop something that can deliver that idea. The trade show is usually the result of that process. So that's why I'm talking about, what I was talking about before about the laser particle size. That is emerging technology. There is some of it around now. Probably within the next 10 years, it will be legislated in many regions.
And then research and development is very expensive. How do you fund that? Do you fund it internally, or does government give support to it?
The government, to some degree, give us a tax incentive to do it. They don't support it directly, but that in one way is support. But it's the most important part of our business. We spend more than 20% of our revenue on R&D, and that's really about knowing where to go and producing the future. But it takes a long time. It takes between 2 and 3 years to produce from the idea to produce a new product. So there are many stages, and some fail. Some don't make it.
And how do you have quite a strict regime that it has sort of gateways it has to pass through in that? Because it can be difficult when you think it's a great idea. How long do you keep on at it before you say, okay, that hasn't worked? What are those gateways for you?
Well, there's obviously the marketing gateway. So we do a fair bit of marketing research, and that includes the regulatory bodies. So if I took the example of the New South Wales government, they wanted to change things. They didn't know how to do it, and they were looking for ideas. So that was an easy gateway for us, because once you said this is what you can do, they said, yep, okay, we'll legislate it. So that becomes a very easy mark. Many of the areas we work in are like that. So the relationships with the governments and the government lobby bodies are very important. But for other products that we make where there's no regulatory framework, the marketing is the key thing, and selling the benefit to the end user is what you need to do. And that, if you can come up with that story and that idea, then you can develop a good marketing plan, and then it's a mathematical problem really, because you can estimate what it is, and from that you can work out how much you really want to spend on it, and then that becomes your next gateway. Here's a potential marketing plan, here's a potential revenue, how much do we want to invest, and how return on investment becomes an issue, and then it becomes a really simple set of KPIs.
And David, do you get involved with other governments besides the Australian government?
Yes, we do. We've been involved in many governments. We've written stuff for the UK government, for the Malaysian government, many of the South Pacific Islands, New Zealand. We've been involved with their government, Vietnam. So we've become quite a resource for many, for this what could be type scenario. And then their next step is to say, okay, so now you've got this piece of instrumentation. What sort of rule framework do we need to support that?
And now we've had COVID over the last couple of years, and we're sort of getting back to living with COVID. What sort of impact has that had on you in terms of supply chain?
There were several impacts. The most obvious one, every time there was a lockdown, you saw the sales figures go down by 30%. That was a direct and immediate impact. That didn't stop our core business because, of course, that was different in every country. So different intervals and different. Overall, it was challenging in terms of sales. We spent a lot of the last 2 years doing R&D and tidying that up, less distracted. The supply chain is probably the biggest issue, and we saw supply chain issues emerging in December of 2019, which of course when China was just starting to experience their COVID and weren't even sure that it was COVID then. But they locked up the much of the the circuit board industry, which is where we saw some of the first problems emerging. And it's since extended right across the chain. The most complicated thing at the minute is semiconductors, microprocessors in particular, where there are 50-week lead times. So that's caused us to redesign certain products just to be able to adapt.
And are you having problems with shipping?
A shortage of containers, yeah. The logistics part is more complicated, but not for us is not the biggest limitation. The biggest limitation is actually supply of the raw material.
And in terms of legislation changes, do you anticipate a lot of legislation changes going forward, and how will that impact your business?
In the braking area, I'm not anticipating anything significant. In the emissions area, I think we're at the start of a huge set of changes. It's difficult to know we have a new government, so it's difficult to know what they will want to change or what bent they'll put on it. But it's my belief in Australia, we don't yet have a 100% viable solution for low emission transport. The most likely seems to be hydrogen. And of course that means it'll be still an internal combustion engine. The emissions will be water though. So from that point of view, there'll be significant changes in what the measurement. But the traditional internal combustion engine, diesel and petrol and gas, I had always believed they will tax it out of existence. So the tax on the fuel or the engine or however they're going to do it. What they've done in Europe is they have annual inspections, which is probably an easy way for them. So they'll set an emission limit and you'll have your car inspected each year. And if you don't meet the limit, you have to have it repaired or you have to dispose of the vehicle and you can't register it. So that's probably the easiest way for a government to deal with it. Taxing the fuel doesn't actually change the quality of the engine or the fuel. So the emissions stay the same, although there would be less of them. So there'll be changes like that in my belief. The instrumentation itself over the next 10 years will have to get better because we'll be measuring lower amounts of the same thing. So the resolution and the accuracy will have to change. And there'll inevitably be technology changes to deal with that.
And can you share with us what products you're currently working on that you're looking to launch in the future? Can you tell us what you're doing and what changes those will make to your business?
Outside our traditional space, where we've moved into more reliability type areas. So, for example, the brake triangle, traditionally we looked at just the brakes themselves, but of course there's 3 or 4 parts to a brake. One's the tyre, one's the suspension, and one's the fluid, and then you've got the friction material. So we've always been in the brake fluid and the friction material area. More recently, we've moved into the suspension area, and we're looking at another set of methods of measuring suspension. So that product should be available towards the early part of next year, 2023. And suspension's important in braking as the shock absorber particularly is what keeps the tyre on the ground. So the brake might work, but if the tyre's not on the ground, you're not going to slow down. There's there's a lot of work happened over the last 10 years internationally in terms of measurement. So there's a couple of theories that have come out on what would be the right measurement. But anyway, we've been working in that space for a while, and we'll have a new product shortly.
Yeah, we're moving towards a greener future. You've mentioned that a couple of times with the government changing legislation in Australia. What are you doing in that space to assist in automotive?
We're moving our traditional emission equipment. So we're looking at laser particle counting. So we're looking to cover what's going to happen in the future. The advantage for the government with hydrogen, for example, is there is only water as the only emission. That area will not be around, but there'll still be gas, and for another probably 20 years in Australia, there'll still be that area. In terms of emissions of the future, hydrogen leakage, there's what they call outgassing from lithium. So there are other areas within the car where there'll be emissions that they will want to control, particularly the hydrocarbon and lithium areas. Hydrogen leakage will be another issue. Because of course, when hydrogen mixes with oxygen, you've got a hydrogen bomb. The technology with hydrogen, it's a whole new industry. So a typical gas tank at the minute with LPG, the pressure involved is 10 megapascals. With hydrogen will be 100 megapascals. So there are all sorts of engineering issues in developing a tank to store hydrogen that can withstand an accident and not leak, won't crack, and you've got to be able to fill it up as well. So there's different issues with pumps and sorts of things. So it's quite a big change, and there'll be new things that we need to do.
I believe they've started to make some inroads in terms of that whole space of how they can transport the hydrogen and operate it. It doesn't need to be at that pressure, I believe. I don't know much about that sector. So. But I think there's some interesting things happening in that whole hydrogen engine space.
Absolutely. And that was the biggest technological problem to start out with is how do you build a tank that can have 100 megapascals, or store a gas at 100 megapascals pressure. And then straight away there was carbon fibre tanks brought up. And then the next issue was, of course, the pump. How do you get the gas into that at that pressure? So there's a huge chain of engineering modifications or designs that need to occur. And then, the last bit will be the consumer. How do you fill your petrol tank up or your hydrogen tank up at the gas station? But that's coming, and there'll be all sorts of things that need to change to deal with that. Yeah, there are always engineering issues. I was in Berlin in 2008 at a conference there, and they were showcasing electric vehicles, and they took us to a demonstration site which was parking meters. And the first thing you notice about the car that was plugged into the parking meter, so this is a meter where you put your dollar in and it gives you a certain amount of energy and pays for your parking for that time as well, was that the car was plugged in with an ordinary household extension cord, and the extension cord came from the roadside of the vehicle, round the back of it, across the footpath and into the parking meter. So the first question I had is who looks after the extension cord? Is that the owner of the car, or is that the council or whatever? And then what happens when a fellow with his drinks is delivering drinks to the milk bar on the corner, when he runs his hand trolley over it and damages the cord? And of course, this is a 240 volt cord that you have there. And of course, there were no answers. At that time, there was no standardization on the plugs or anything. And that's got a lot better, but if you go to the charging stations that some of the councils are installing, of course, the cord is now part of the meter, so that obviously the council owns that. But there are lots of standards that have to change in a car too. So, for example, today, an electric car still has to do an emission test, and that's really because the government haven't changed the standards. Of course, we know what the emissions will be, but they still have to go through the paperwork. So there are lots of regulatory changes that need to embrace the new technology. And at the minute, it's the technology that's driving the regulation, not the regulation driving the technology. And in Australia, that's been the case since the early 80s.
David, thanks very much for joining us today. We really appreciate your time, and we enjoyed it. It was a really great discussion and very interesting about what the future is in the measuring equipment game. So,
yeah, thank you, John. Pleasure.
thanks very much for listening. I hope you enjoyed the interview with AutoTest as much as I did. It's a fascinating part of the automotive industry, and it's amazing all the things they're doing and what happens in the background that we don't always know about. If you enjoyed what you heard, subscribe to our channel below. You can also find us on iTunes and Spotify, and we also have our own website, autocurrence.com.